All right, so we're going to do a thing called inscribed angles. So let's put a circle here and show you what an inscribed angle is. There's a definition for it in the book. Let me read it. If I just read it to you, you'd probably think, what in the world did he just say? I have no idea what that meant, but I'll draw a picture for you. That'd be a lot easier. But here's what the definition says. It's in the book. I'm just reading it straight from what the book says. An inscribed angle is an angle whose vertex, so we got an angle, right? And the vertex of that angle is a point on the circle, and the sides are chords of the circle. You're like, okay, you had me at vertex and then I got lost. Well, it says it's an angle whose vertex is, what did I say? It's on the circle. Everybody watching my picture here? There's an angle, would you agree? The vertex is on the circle because the vertex of the angle is right there. And the sides of that angle are chords of the circle. You hear what I said? That's basically the definition. Okay, that's called a what? An inscribed angle. That's different from what we've been doing. We've been talking about what other angle. We just did a whole bunch of problems. Well, we did a few problems earlier, and we had an angle that's where? It starts at the center. What did we call that angle? No. We call that the central angle. Okay? So there's a difference between the central angle and the inscribed angle. And I'll show you right now. So if this was like 70 degrees, that central angle, then what is this arc that it cuts off? 70 degrees. That was easy, right? The angle and the arc are exactly the same. But that's only when the angle is a what kind of an angle? A central angle. Okay? This is not a central angle. So let's say this is a little skinnier. Let's say this is like 20 degrees. Does that mean that this arc that it cuts off from here, we'll just give it a letter.
It's not a central angle.
That's right. It's not a central angle. This is 20 degrees. This is not 20 degrees. All right? Am I ready to tell you this? Yeah, let's just do it right now. There's a theorem that says this. It says that the inscribed angle is half of the arc that it cuts off. Do you hear me?
Yeah.
The inscribed angle, if I told you it was 20 degrees, that is half of the arc that it cuts off. So what's the arc? It's 40. Or you could say it another way. You could say the arc is what? Double the inscribed angle. You hear me?
That's always true.
It's always true when it's an inscribed angle in a circle. Okay? So the angle is half of the arc, or you could say the arc is double or twice the angle. Okay? That's a theorem. All right? There is a proof for it. We're not going to go through it. I'm just going to tell you what it is. Just believe me that it's true. Okay? Don't just believe me. It's the book says it, and everybody in history has said it, so it's not just me. But there is proof in the book. If you want to look at it, feel free. We're not going to. All right? Let's do another quick little thing. Let's make this a little smaller. This is not really super important. I could probably even not even do it. It probably wouldn't make any difference, but I'm going to. All right, so what if we had, I'm going to draw several inscribed angles. I'm going to draw one that looks just like the one we just did. I'm going to draw another one that does this. It's also an inscribed angle, would you agree? And then here's another inscribed angle. Oops. Let's start here. All right, and the only thing, I don't know if even practically we're going to use this, but I'll just say it anyway. Look at the center of the circle on all three of these. Where is the center of the circle to this inscribed angle? So here's your inscribed angle right here. The center of the circle is outside of the angle, isn't it? So we say the center is the exterior or in the exterior of this angle. You with me? So the center of the circle, they've got this in the book if you want to look at it. The center of the circle is in the exterior of this angle because it's outside the angle. Make sense? We've talked about exterior before, no big deal. What about right here? Where's the center of the circle? It's on, or it's yeah, we say it's on the inscribed angle. It's actually on the angle itself. Everybody got it? So we're talking about the center of this. The center is on the inscribed angle. Where is the center with this angle? It's inside. Or if we said exterior here, we're going to say what? Interior, right. So this is in the interior of the angle. Do you see where it's inside the angle? This one, it's outside the angle. This one, it's on the angle. Yeah. All right. Enough of that. That was easy. Let's do an example. Let's make this a little bit bigger so we can see it. All right, I'm going to draw a bunch of lines here. So just bear with me. Draw this as I'm drawing it, and then we'll keep you busy, keep you out of trouble. And we got another one that goes to here, and we got another one that goes to here. That's pretty close to what they have in the book. All right, let's label it. So that one's Z, that's Y, this is X, this is W, and this is V. They also give you some measurements. They say that arc is 60 degrees and this angle is 55 degrees. There you go. All right, so here they ask you a couple things. They say find the measure of these two things. So find the measure of angle VYW, and then we'll put B down here. Then find the measure of arc. So this is what we're trying to find. We're trying to find these two things right here. All right. Now, what do we know about the inscribed angle? It's half of the arc, right? The arc is double the angle. So let's do this. Now let's just try to solve what they want. VYW. Where is V? VYW. Angle. Oh my goodness, that's easy. It's that angle right there. That's what we're trying to find right now. Well, look at that angle. Where does it go? It goes to here, and it goes to here. So it cuts off.
That means that the Y is half of the arc.
That's right.
The arc is double, so it means it's 30 degrees.
Exactly right. So if you look at this angle, this is an inscribed angle. Okay, it cuts off that arc. They told us what that arc was. Remember, the arc is double the angle. Okay, or the angle is half the arc. So if the arc is 60, then this would be 30. Easy. So what's our math? Just 60 over 2, right? That's our work that we have to show. All right? Vx, the arc, it is 110. Very good. So that's going to help us find what they ask you to solve for, okay? So Nate had it right on. So take a look at this angle, 55. Where does it go? It goes to V, and it goes to X. Right, so from here to here is what? 110. Watch. Okay. See how excited everybody is now? So watch, that whole thing is 110. This little bit's 60, but what are they asking for? They're asking for this right there, okay? And so you just take 60 away from 110, and what is that? It's 50 degrees. And so what's the math here? We'll just say, we'll say 2 times 55 to get the 110, right? And then we take the 110 and we subtract what? 60 from it, and you get 50. So there's the work, okay? People wonder, why do we, how do you show work on this? This is how you show work. Even if it's as easy as just going 60 divided by 2. Write it down. 60 over 2 is 30. Same thing here. Show your work. All right, we good? All right, let me show you a couple other things. So inscribed angles, pretty simple, isn't it? Just the arc is double the angle, or the angle is what? Half of the arc. Okay. Let's do this. I don't need it that far over. Let's come on. There we go. And then put it right here. Watch this. This is a theorem. I'm just going to draw it out. I'm not going to write out the theorem. I'll read it to you in just a second. And then I'm trying to make these angles the same, okay? So these two angles are equal to each other. Let's just put a number in here just to show that they're equal. Let's say that's 30, and then this would be 30, okay? Now here's what the theorem says. It's kind of self-explanatory. To tell you the truth, you could probably figure this out without them telling you this theorem. That inscribed angle thing, you may not have been able to figure that out on your own, but this one you could. All right, it says incongruent circles. What does that mean, congruent circles? It means, they're equal circles, but it means the radius is exactly the same on both of them, okay? That's what it means by congruent circles. It says, here's what it says. When you have congruent circles, or if you just have one big circle and two inscribed angles in one big circle, okay, it works the same way. So incongruent circles or the same circle, inscribed angles, these two angles right here, are congruent if and only if they intercept congruent arcs. So it goes both ways. So if these two arcs are congruent, what's true about the inscribed angles? They're congruent, okay? If the angles are congruent, then what's true about the arcs? They're congruent. I told you could probably figure that out on your own, couldn't you? Because if this was 30, then this would be what? 60. So if this was 30, if I told you those two angles were the same, that must mean that this is double this, and this is double the same exact thing, right? So they've got to be equal to each other. And it goes both ways. If I told you that the arcs were 60, I could tell you that both of those angles were equal. That was no big deal. Now, this next thing I think is pretty cool. I think this is one of the most interesting things about this whole circle thing. So this is kind of cool. What I'm going to do is I'm going to draw a semicircle. All right, so that means I'm going to draw a diameter. Okay, watch this. I think this is really interesting. What if I draw an inscribed angle that cuts off a semicircle? Do you hear what I just said? An inscribed angle that cuts off a semicircle. That means both of the ends of those angles are going to hit at one point on the diameter and another point on the diameter. Okay, so watch this. Just watch. So if I just took this up to here, and then I took this to here, and this is really cool. What's this angle going to be right here, do you think? What does it look like it's going to be? It looks like a right angle, doesn't it? And it's actually always going to be a right angle. Anytime that you have an inscribed angle and it cuts off a semicircle, you're always going to get a right angle. And I didn't here, I'll just show you this. I didn't just draw this a certain way to make it a right angle. Like I didn't pick the exact spot on the circle to make that a right angle. Okay, watch this. If I had another diameter right here, oops, and
Teachers and students, just an update on one of the sports dismissals. Varsity girls soccer, you are dismissed at 2 o'clock and you will be leaving at 2:30. Thank you.
Watch, what if I picked a different spot on that circle? Let's say I went to here. Completely different spot. Would you agree?
Yeah,
and then I went from here to here. It still gives me a what? A right angle. Now, let's think about why that's true. Because there's a reason. You saw it, Kiki. Tell me. That's right. Because it cuts off 180 degrees. So look. Let's do this. I'm going to try. There you go. That's close. Everybody watch. I want you to see why this is true. I want you to see why this is always going to be a 90-degree angle. Because this inscribed angle cuts off a semicircle, right? So how many degrees is a semicircle? 180 degrees. So an inscribed angle is always what of the arc? It's always half the arc, isn't it? So if a semicircle is always 180, what's half of 180? It's 90. So this is always going to be 90. It doesn't matter where you draw it on the circle, it's always going to be 90. All right? That's kind of cool. Would you agree?
Yeah.
Let me do one more thing. I know the bell's not ringing, but they always start chapel late anyway, so you can be a couple minutes.
No, it's a good chapel today.
I just said, I didn't say you're going to miss chapel. I said it starts late anyway, so you're not going to miss anything. That's the point. I don't want you to miss chapel. Here we go. We're not done. I want you to watch this.
I love this place.
Watch. This is kind of interesting as well. I won't explain it. I'll just show you what's true. So what do we have inside of this circle? Well, we don't know it's a trapezoid. We don't know it's a rhombus. What's the only thing we don't? All we know is it's a quadrilateral. Okay, there's nothing special about it. None of the sides are equal or parallel or anything. Watch, everybody, look up here. Look up here. We're not done. Everybody, look up here. So we have a quadrilateral. Now we have, listen, we have a theorem that says this: that the opposite angles of a quadrilateral, we say it's inscribed in a circle. Why is it inscribed? Because the vertices all hit right on the circle. Do you see that? So this is called an inscribed quadrilateral. All right. What we know about this is that the opposite angles A and C, they're not congruent to each other. They are supplementary. Okay, so they add up to 180. So what else adds up to 180 in here? B and D. So angle B plus angle D is also 180 degrees. Now, we ran out of time to do the example, but you may want to look at that example on your own. But here's your homework. It's section 8.4. I'm going to split it up into two.
Is this on the
It's on the lesson plan, yes. But just in case somebody's watching it on YouTube and need to know, there it is. Okay, so that's your homework. Let's have that finished for tomorrow. Oh, by the way, listen real quick. On the lesson, listen please. We're not listening. Listen to me. On the lesson plans, it says we take a quiz on Friday. I'm going to push that to Monday.
Yes.
All right? So I'm going to push it to Monday. I don't think we have enough time
Don't be excited
to do
about
that.
Monday.